Welcome, everyone. Today we will be discussing the differences between pure substances and mixtures, exploring the various types of mixtures, and understanding the properties of true solutions. Let's begin by taking a look at the different types of mixtures. Solutions, suspensions, colloids, and emulsions are the four different types of mixtures found in nature. Solutions contain two or more substances that are evenly distributed and cannot be easily separated. Suspensions are mixtures of two or more substances that are not evenly distributed. Colloids are mixtures with a dispersed phase that appears to be uniformly spread throughout the mixture. Emulsions are mixtures that contain two immiscible liquids held together by a third substance. We can observe the two main types of matter in this slide. Pure substances and mixtures. Pure substances are further divided into elements and compounds. Homogeneous and heterogeneous mixtures are the two forms of mixtures. Acquiring knowledge of the differences between pure substances and mixtures is imperative. Pure substances consist of one type of molecule, cannot be broken down into anything else and have their own properties, while mixtures are composed of two or more types of molecules, can be separated by physical means into their components and take on the properties of their components. Water is an example of a pure substance, as it is the same no matter where it is found. Seawater, which has a higher salt content than freshwater, is an example of a mixture. We are discussing two types of mixtures. A homogeneous mixture has a uniform composition and particles that cannot be seen with the naked eye. It also cannot be separated by filtration and is stable. Also, a beam of light will not be visible when shown through the mixture. Examples include sugar in water, salt in water, and copper sulfate in water. A heterogeneous mixture has a non-uniform composition, particles visible to the naked eye, and the particles can be separated by filtration. Furthermore, the mixture is unstable and a beam of light will be visible when shown through the mixture. Examples include salt and sand, sulfur and iron filings, and oil and water. A true solution is a homogeneous mixture of two or more substances, with a solvent and a solute as its components. The substance in greater amount is the solvent, while the one in lesser amount is the solute. Examples of solutions are salt in water, sugar in water, iodine in water or soda water. True solutions have several properties. They are homogeneous mixtures, with particles too small to be seen with the naked eye. The solute particles can't be separated through filtration. They don't settle down, making the solution stable. And the particles don't scatter the beam of light passing through it, so its path is not visible. Particles in a colloidal solution are suspended in a medium and cannot be filtered out. These types of mixtures appear foggy or cloudy and examples include milk, smoke-filled air, and a mixture of starch and water. Unlike suspensions, a colloidal solution is stable and does not settle out over time. Additionally, a beam of light passing through this type of solution will scatter, making the path of the light visible. All in all, colloidal solutions are heterogeneous mixtures of two or more substances, possessing properties that differentiate them from other mixtures or solutions. Suspensions are heterogeneous mixtures of two or more substances, with examples such as a solution of sand in water, or a solution of chalk powder in water. These mixtures have four particular properties. Firstly, being heterogeneous mixtures, the particles can be seen by the naked eye. Secondly, the solute particles can be separated by filtration. Thirdly, the solute particles settle down, making the solution unstable. Finally, the particles scatter a beam of light passing through it, creating a visible path of light in the solution. Solute particles can be separated from a solution using sedimentation and filtration. During sedimentation, the particles settle down and the solution becomes unstable, while filtration uses a porous material to separate particles from a liquid or gas. A suspension is a heterogeneous mixture that scatters light and shows a visible path of light, known as the Tyndall effect. AG-PICS Fundamental 0176 displays the differences between pure substances and mixtures. Light shown through a colloidal solution will create a visible path due to the particles scattering the light. This is known as the Tyndall effect. We can observe this effect in everyday life. Light from a small opening in a dark room will be scattered by dust and smoke particles, and a dense forest may appear brighter due to water droplets scattering the light in the mist. A solution is considered saturated when no more solute can be dissolved in it at a given temperature. The solubility of a substance is measured in terms of the amount of solute present in a saturated solution. An unsaturated solution, however, is one in which more solute can still be dissolved under the same temperature. To create a saturated solution, one would add salt or sugar to a set amount of water, stirring continuously until no further solute can be dissolved. It is important to note that the solubility of different substances may differ, and that solubility can be impacted by temperature. Concentration of a solution can be expressed as the ratio between the amount of solute and amount of solvent or solution. This ratio can be determined either as mass by mass percentage or mass by volume percentage. Mass by mass percentage is calculated as the ratio between mass of solute and mass of the solution, while mass by volume percentage is the ratio between mass of solute and the volume of the solution. Separating the components of a mixture is a way to identify and analyze individual elements of a mixture. There are various techniques used for this purpose, ranging from everyday methods to complex special techniques. These include handpicking, sieving, filtration, evaporation, centrifugation, decantation, sublimation, chromatography, distillation, and fractional distillation. Each technique has its own pros and cons depending on the type of mixture and its components. Evaporation is a method used to separate a volatile component, solvent, from a non-volatile component, solute. For example, heating ink in a dish causes the water to evaporate, leaving the dye in the dish. This method can also be used to separate a mixture of salt and water or sugar and water. To conduct evaporation, the mixture should be heated on a stand, over a wire gauze. Centrifugation is the process of separating denser particles from lighter ones in a mixture by spinning it in a centrifuge machine. By spinning in a centrifuge machine, the particles that are more dense will be pushed to the edges of the container, while the lighter particles will remain in the center. One example of this is taking some milk and spinning it in a centrifuge machine, where the cream would be pushed to the edges, separating from the milk, because the cream is less dense than milk. Decantation is a type of mechanical separation used to separate immiscible liquids like oil and water. This is done by using a separating funnel, where the liquid with the highest density settles down and can be separated from the lighter liquid. As an example, a mixture of kerosene oil and water is used. By allowing the mixture to remain undisturbed in the funnel, the kerosene oil settles down while the water is separated from it by opening the stopcock. After the water is separated, the stopcock can be closed once again. Sublimation is a method of separation that works when a mixture of a sublimable and a non-sublimable component is present. When heated, the sublimable component changes into vapors and can be cooled and solidified separate from the non-sublimable component. An example of this is a combination of ammonium chloride and common salt. After being heated, the ammonium chloride sublimes and can be collected, leaving the salt behind. To make sure the method works properly, the correct equipment needs to be used, such as an inverted funnel, cotton, china dish, and burner. Chromatography is a scientific method used to separate the colored components in a mixture. It involves placing a drop of the mixture solution on a strip of filter paper and then dipping the paper into a test tube of water. As the water moves up the paper, the components of the mixture will rise at different rates and separate from one another. This can be used to identify and analyze the components of a mixture, allowing us to know exactly what it contains. Chromatography is a powerful tool in the field of chemistry that enables us to understand how mixtures work. Distillation is a process used to separate mixtures of miscible liquids that differ in their boiling points. Simple distillation can be used for a mixture of two liquids, such as a mixture of acetone and water. In a distillation apparatus, the acetone will boil at a lower temperature than the water. The separation is done by cooling and condensing the vapors. Fractional distillation is a process employed to separate miscible liquids with boiling points within 25 K of each other. The equipment for this process is analogous to that of simple distillation, only featuring a fractionating column with glass beads that provides maximum surface area for vapors to condense. This method is frequently used for separating petroleum components, gases from air, or mixtures in laboratories. Compressing air and cooling it with an increase in pressure and decrease in temperature forms liquid air. This liquid air is then slowly warmed in a fractional distillation column, allowing the gases to be separated based on their different boiling points. Oxygen boils at 183 degrees Celsius, argon at 186 degrees, and nitrogen at 196 degrees. Fractional distillation enables us to accurately separate the components of air from a mixture. In this slide, we have a description of the process of purification of solid by crystallization. Crystallization is a method of purifying a solid, by obtaining its pure form in the form of crystals from its solution. Copper sulfate is an example that is used, in which an impure solution of copper sulfate is filtered to remove impurities, then saturated with water by evaporating it in a china dish. When the solution is cooled, pure copper sulfate crystals are formed. The slide we are looking at contains information about the two types of pure substances, elements and compounds. Elements can be further divided into three types: metals, nonmetals, and metalloids. Metals have properties such as luster, malleability, ductility, being good conductors of heat and electricity, and being sonorous. Non-metals, on the other hand, do not have luster, are not malleable or ductile, and are poor conductors of heat and electricity. Metalloids, as the name implies, have properties of both metals and non-metals. Examples of elements and compounds are known to all of us: iron, zinc, mercury, aluminum, hydrogen, oxygen, nitrogen, and carbon, to name a few. Compounds are pure substances composed of two or more elements chemically combined together in a fixed ratio. Examples of compounds include water, carbon dioxide, sugar, salt, and iron sulfide. Mixtures and compounds differ in that mixtures are composed of two or more elements or compounds, while compounds are composed of two or more elements chemically combined together. Mixtures can have any ratio of components while compounds have a fixed ratio. Also, mixtures show the properties of their individual components, while compounds often have different properties than those of the individual components. Lastly, mixtures can be separated by physical means, while compounds must be separated by chemical means. Thank you for listening.